Last week, we worked on determining the best attributes for each entity and drawing ER diagrams. So far, this week, we have taken a look at functional dependency to assist with finding the right attributes. We will now take a look at a method called normalization, which is used to fine-tune and eliminate any potential problems that may exist in a table structure. There are several steps of normalization, but we will focus on the first three. Most companies make it their goal to have tables normalized to third normal form. If you're interested in normal forms 4 through 7, they are included in your textbook. First normal form, or 1NF, is completed to remove repeating columns or rows. Second normal form, or 2NF, uses functional dependency we learned earlier to ensure all attributes are dependent on the primary key. Third normal form, or 3NF, ensures there are no calculated columns or other abnormalities in the tables. Let's take a look at each of these normal forms separately and look at some examples. A table is in first normal form if it does not contain any repeating groups. This means that each cell in the table contains one piece of information and the data is not separated by commas or on a second line like you see from figure 2.7. You likely will not set up your tables this way, but if you do get data from a client, you will know what step to take first to get it database ready. To fix this, all you have to do is put each piece of data on its own line and repeat the information in the other columns as you see in figure 2.8. This does mean that you no longer have a single column as a primary key. You now have the composite primary key of order number and part number. Before we move on to second normal form, let's take a look at some other examples of repeating groups and ensuring tables are in first normal form. Sometimes the repeating groups appear as repeating columns, as in this example. This table is in violation of first normal form due to repeating columns. Item 1, Item 2, and Item 3. The issue arises when the customer wants to order a fourth item. To purchase a new item, a new column would have to be added. Tables should be designed correctly initially so that columns will not need to be added. To solve this issue, all you have to do is put each of these items on its own separate row. Putting the items on its own row did the trick, and we are no longer in violation of first normal form. We do, however, have a single primary key and must combine the order ID and the item to make a composite primary key. While converting to first normal form, do not worry about functional dependencies. These come into play in second normal form. Remember, our goal is to get to third normal form, and each of these normal forms is another step to get us there. Also, while completing the examples for this video, I will be showing the table representation with data because the data is what helps tell the story and determine the primary keys and foreign keys. However, I will put the shorthand notation below every table so you can get used to seeing that notation. On exams and in the real world, you will see the table structures in shorthand notation and table format. Pay close attention to this example of how repeating data is represented by a second set of parentheses. All you have to do in shorthand notation to get to first normal form is to remove the second set of parentheses like you see here. Sometimes the repeating groups appears as repeating information in a cell, as in this example. This table is in violation of first normal form due to having more than one piece of data in the product field. To fix this, put the repeating information in the other columns and use the invoice number and product ID to make up the composite primary key. The shorthand notation would be as you see here. Now on to second normal form. A table is in second normal form if it is already in first normal form, each table is about only one entity, and all non-key attributes are functionally dependent on the primary key. Looking at figure 210, the top orders table is in first normal form, but the attributes are not dependent on the primary key. And there should be more than one entity. For this example, you applied the functional dependency process you learned earlier to form the three tables. The shorthand notation for the three new tables looks like this. Okay. Now let's move on to third normal form. For third normal form, the table must be in second normal form with no dependencies that were missed and have no calculated columns. This is an example of with a calculated column. Which column do you think is calculated? If you said the total column, you are correct. To convert to third normal form, all you have to do is remove the calculated column. That wraps up normalization, or as far as we get into it for this class. You are now ready to try the normalization assignment.